Hello everyone, my name is Ishant Kumar, and today we'll be solving another problem which is going to be 01 game. It has a tag of games currently 900 rated on Codeforces. So let's read the problem. Alyssa, and Bob are playing a game. Initially, they have a binary string S consisting of only characters zeros and ones. Alice and Bob make alternating moves. Alice makes the first move, Bob makes the second move, Alice makes the third, and so on. During each move, the current player must choose two different adjacent characters of string S and delete them. For example, the example is given here. Let's say the string given here is this. In first move, we can just choose two adjacent numbers, two adjacent different adjacent numbers. So for the first case, we have taken these two. We can take these two also, or anything like that. So if let's continue. If a player can't make any move, they lose. Both players play optimally. You have to determine if Alice can win. Okay. So let's look at the input and what we have to provide as an output. So as an input will be given T, which is going to be the number of test cases. Under each T will get an S, which is going to be the binary string. And as an output, we have to say if Alice can win the win the match or not. If he wins, we have to give DA, which translates as yes in Russian. For some reason, we have to give in Russian language. I don't know. And otherwise, we have to print net. If Alice wins, we have to give DA, which is yes, and net, which is no. So let's see what the problem is trying to say. So initially we are given a binary string. So what is a binary string? Binary string is a type of string which consists of only two elements. It contains only two things, which is going to be 1 and 0. It is a string, type of string, which consists of only ones and twos. N number of ones and n number of zero should be there, no two, sorry. N number of zeros can be there. It consists of only two elements, ones and zeros. What the problem is trying to say is that since Alice and Bob are playing a game, in game they are given a binary string, and in one move, one person or one player can eliminate two different adjacent elements. Meaning, we cannot eliminate two similar elements like 0 0 or 1 1. We have to eliminate two different adjacent numbers. Adjacent meaning they has to the both the numbers should be like side by side to each other. So in one move, we can eliminate those two different adjacent elements. And as an output, we have to find out if Alice can win the game or not. So let's look at the logic for this problem. Let's take one test case. Let's take this one also. Let's paste it here. So for this test case, S is equal to 1 1 0 0 and 1. This is the binary string that we were talking about. It consists of only ones and zeros. So what we are going to do in this problem is that initially we have to find out how many moves overall both the players can make, and after finding that, it will be easy to predict the output since the primary thing is to find out the number of moves overall the player can make. So how can we find out? Since the game in the game it is mentioned that we have to eliminate two different elements. So the number of moves is dependent on both the number of zeros and the number of ones for this problem. Meaning, let's say in this test case, the number of ones, let's first calculate the number of ones and number of zeros in each case. That will be easier to understand. So number of ones in this case is 3 and the number of zeros in this case is 2. So since we can select two elements at a time and the number of ones is 3 and the number of zeros is 3 and two adjust different elements. So uh, I can say that, let's say I select these two in the first move and these two in the second move. I will be left with one, and I won't be able to make any move since we can only eliminate two elements, two different elements at a time. So, by counting these two elements, what we can figure out that we can only make the number of moves to which the element is the minimum, meaning out of ones and out of the count of ones and the count of twos, whichever element is present in minimum, either it is equal, it is fine. But if any of the element is like lower to the other one, then we will be able to make the minimum number of that element. Like in this case, we will be able to make only two moves, as we have discussed earlier. First, we'll eliminate these two. After that, we'll eliminate these two, and that will be game over because this only one will be left and we won't be able to do anything out of that. So the number of moves will be equal to the minimum count of ones and zeros in the binary string that we have. So now that we have the number of moves, let's see how can we predict the output of each game or each test case that we have given. So let's take this test case. So let's take here the number of moves for this will be 2, sorry. Number of moves for this test case will be 2. So in the first move, since Alice is starting, so in the first move, Alice will take the chance and will eliminate, let's say, these two numbers. So after that, after Alice's chance, this will be the string. So after Alice, Bob will make the next move. So after that, sorry, so like I'll just repeat it. So the number of moves, it will be the minimum of one or zeros. They are present in the string. After that, the minimum number of moves for this test case is 2, since there is only the minimum number of uh, out of ones and twos is 0, which is 2. We can only make two moves. So in the first move, Alice takes his chance and removes two elements, which will be after removing, let's say, remove these two. So after removing, the string should look like this. Let's say after Alice, Bob will take his chance and Bob will remove these two, since we have to remove two different adjacent elements. So the string will look like this, and after that, after Bob, Alice has to play. So for Alice, there is only one element left in the string, and it is only one. So initially, Alice will lose since there is no chance to like play, since it is written in the problem. If a player can't make any move, they lose. This is the losing criteria for this problem. And for this test case, Alice will lose and Bob will win. So for this, the output will be, it was NET, which translates as no in Russian. There we have to print the output in Russian for some reason. So that is going to be the logic. If the number of moves, uh, I am forgetting something. Let's see. Yeah, so for this test case, the number of moves is 2, which is even. So in this case, Bob is winning. I'll say Bob wins. But let's say for some test case, the number of moves is odd. Let's say the number of moves for some test case is 3. What will happen in that case? It means the number of moves is odd. Firstly, Alice will take his chance. After that, Bob. after that Alice, and after that once again Bob. But since technically there are only three moves that we can make, as seen in here, that there are only two technical moves that we could make, and we'll be left with a single element at the end. And after after Alice's turn, Bob will be left with one single element, and he won't be able to make any choices, and he will eventually lose, and Alice will win. So let's say for every test case, if the number of moves is odd, Alice will win, and if the number of moves is even, Bob will win. So this is going to be the logic for this problem. Initially, we have to calculate the number of moves that we could make. We can calculate it by taking the minimum count of ones and zeros in the string. After that, if the moves we can make is even, Bob will win and Alice will lose. And initially, the output will be net, uh, which we have to give when Alice loses, and if Alice wins, which is possible in all the cases where number of moves are odd, we have to give DA. So this is going to be the logic for this problem. Let's look at the code. So here I've taken T, which is going to be the number of test cases. After that, I've declared a string and taken input of a string, and I've just in the length I've taken the length of the string. Here I am counting the number of zeros and the number of ones in the binary string. After that, I'm here calculating the number of moves, which is going to be the minimum count of zeros and ones. After that, if the number of twos is is even, then Alice will lose. I'll just mention it here. Alice loses, and we give an output of NET. And else, like if the number of moves is odd, then Alice will win. So this is the logic for this problem. Let's test this case for the test cases that are given here and check if our logic is correct or not. So this is problem number 1373 B, I guess it is B. Yeah, it's B. It's 1373B. Let's compare the output. So for the first case, where the number of counts is odd, which is 1 1 for both, so it will be considered as odd. So we'll get a DA, and here also it is we are getting DA. And in the second case, all are ones, and there are no zeros, so we won't be able to. Alice will won't not be able to make any move since there is no different element in this case. So Bob will eventually win. In the third case, there is an odd or even number of moves that will be able to make since the count of zeros and ones is equal to 2. Both are equal and they are even. So Bob will win and will get a net, which is Alice loses. So this was all for this problem. It was pretty easy. We just had to calculate the moves and relate to the pattern that we were getting about the even and odds. After that, we'll get the answer. So that was all for this problem. Thank you.